Good morning, afternoon, or evening to those of you doing Algebra 1. We got, here's our stuff for lesson 69. If you made it this far, you still have a long way to go. How about that? Today we're going to be talking about adding and subtracting radical expressions. If you remember, expressions are these algebraic units which don't have equal signs. Equations do. So it's like an equation without the equal sign. There's no do unto one side as you do unto other things here. We're just going to work at the units themselves. How do we add, subtract expressions that have a radical sign in it? They have the square root or a cubed root sign on them. We want to know when we can do that and when we cannot. And one thing I do want to discuss today are some of the common errors that algebra students, well, really math students in general, will experience, and the things that I've seen over the 18, 19 years of teaching math that students do that are just conceptual hard things like fractions that it just takes a while to kind of see and understand. So I want to warn you about a few of those things and show you kind of how to think about some of these. And the math today really isn't that hard once you see it for what it is. But if you can't see past all the letters and numbers and shapes and stuff in there, then it does get confusing. But let's see, what do we need today? Well, you need your pencil, you need your notebook to write stuff down in, because you're going to want to use this on the test. You're going to want to show your work, and you want to have examples to use. You don't need a calculator today, but you might need a Scottish English dictionary, and spare hubcap might come in handy. I got more than one of these if you need an extra. Homework sheets, these are really helpful for me for grading your work and getting things recorded very quickly. It helps you keep your stuff organized and helps me see everything that you're doing better so that I can help you. All right, I've written up some of the examples that they have in the book, and I know that doesn't terribly help a lot for you to just watch me do exactly what's there in the book. So I want to maybe not even just give you the answers because they're right there. You can go and look at them in that lesson. But what I want to do is kind of talk you through some of the concept things that you might get hung up on that you have to watch out for, or give you a way to think about these things so that you can get to your answer quickly and get on to something else that you want to do, like text your brains out. Okay? So, like terms is something that you've already dealt with. That is an algebra thing that sometimes becomes a problem, because we don't know what to do with those. But we do know that if we start off with something easy like 2x plus 4x, I think we do know what to do with those kinds of things. No matter what x is, we have 2 of them and we have 4 of them. And if we want to combine them, we just take 2 and 4, make 6 of them, whatever those things happen to be. Radicals are the same kind of thing. X is nothing special. We could use any letter we want to. We could use a whole bunch of letters. We could use a word in there and just replace whatever that thing is with something like apples. So to me, calling it a thingy or calling it apples, because I don't know exactly what it is or what it's going to be if I had a number to throw in there, to just call it the thing that's sitting there and I have 2 of them is very helpful to me, because I can count stuff like this pretty easily. When I look at that, I go, oh, what's x and what's y? And then I got to multiply them. I'm going to take the square root, and how's that jive with 4? What is this going to be more than that? It doesn't really matter. If I see that this looks exactly the same way as that does, or as an example with just numbers up here, it says 2 root 7 and 4 root 7. If I just say the word apples instead of root 7, I can simplify my problem down quite a bit and just make it simple addition. I can say 2 apples and 4 apples makes 6 apples, and I just substitute square root of 7 in for apples. So this one is square root of x times y, and there's another one over here, so I'm going to say 4 apples minus 6 apples is negative 2 apples. Of course, you can't have negative apples, but you know what I mean. 4 thingies and take away 6 thingies gives you negative 2 thingies. Whatever. That's when you can do that. You could add or subtract these things because they're like each other. I have 4 of these, I have 6 of these. If you would like to use the distributive property, you could change this into, well, put parentheses around this and say 4 minus 6 times that thing. It's like it's a common factor in both of those expressions. 4 times this minus 6 times that is the same thing as 4 minus 6 times that. Okay, negative 2 square root xy. But you come to one of these, and what your tendency is as a student is, I need to do something with that, right? I need to get an answer for that. And it says I'm supposed to add and subtract these expressions, so I'm going to smush them together. But this one's like an apple, and this one's like an orange. So if you're like, what's 6 apples and 8 oranges? It's 6 apples and 8 oranges, okay? There's no combining there to be done whatsoever because these two things are not like each other. Remember, any of you grow up on Sesame Street? I did. And they used to play that game that one of these things is not like the other, and one of these things just does not belong. So there's some things you can combine, and there's some things that you can't. Your tendency might to be something like this: go 14 and root 13, but that is just complete hogwash. If you take out your calculator and you actually type this in and get some decimal answer, I guarantee you it will not equal this. It will not equal this. You cannot do that. That is like math heresy right there. This is the answer. There's nothing to be done. There's no combining, nothing to be operated on there. It is what it is. This is a prime number. It can't be broken down into smaller pieces. You can't pull anything out of that and make it simpler. You have to know when to stop. Just stop. Okay? It's okay to write that. Say that's it. There's nothing else to do with that. Sometimes they give you a problem where some of the information is something you can do something with, and some of it's not. And so we've got this problem down here where we're looking for things that are like each other and things that are not like the other things. So we look at this, and it's got a root 5q. This one's got a root 5q. So it makes me think that these two could be put together. But this one's got a root of 3r, which is not, I know this is a surprise. It's not a 5q. Hang on, I gotta talk to Mr. Palm. Oh, you gotta be kidding me. Okay, sorry. So what are we doing? I don't know. We can think of this 5q thing as like A and this 3r thing like it's B. So we get like 2/7 of these and 3/7 of the same thing minus 4/7 of something else. Okay? So if we got 2/7 and 3/7, you know that when you add fractions, the numerators can be combined and the denominators, when the denominators are the same. We did that in another lesson. We did this kind of stuff back in lesson 61 where we simplified things first. So 3/7 and 2/7 is 5/7 of these things. And then since we can't do anything here, we leave it like that, except that both of them are something over 7. And so here's what we can do with that and be done with it. We can put everything over 7 and put it in its simplest form. But these can be combined, but they cannot be combined with that. Please do not put like 315RQ under a root sign here. You can't do that. You can't combine these things. They're not like each other. They don't go together. On that note, let me talk about common errors then that students do. One of them there is what I just explained, where you end up adding factors together. Let me give you a simple example of stuff. One of these I already saw on a test. Is something like this. This is the same case where this thing and this thing are different. If x is 10, then this is 100 and that is 10. And you got 3 times 100, 2 times 10. Now obviously you can't do something like 5x cubed and call it good. Though that's kind of our inclination from basic arithmetic is to just put everything together when it's got a plus sign there. But this, again, is like 3 apples and 2 oranges. They're different things. X squared is not like x. X squared is a totally different thing. So this is an error that I commonly see. When you go, I'm supposed to combine, what do? I guess I'll just put everything together because it says add. No, there's nothing to do here because these are not combinable terms. There's not. Unless we knew what x was, and then we'd have to do multiplying. Okay, these are factors. 3 times this. This is a factor. Here's another term right here that has 2 factors. But these factors, the common factors, is just x. You can factor stuff out, but you can't smoosh them together. Factoring and talking about things as factors is multiplication and division, whereby here we're trying to take this whole unit and add it to a whole another. Yeah, and so we're playing with different rules when we do that. This is a very common thing. This is not the answer. There's nothing else to do. That is the answer. You stop because there's no more work to be done here. A second thing has to do with fractions. And I'll give you 2 examples here. This is very similar to that last problem that we just did with the root signs. 2/7 x and 3/7 y. The x and the y are not the same, but they are both sevenths. So there's a part of this that we can put together, part of it that we can't. If they're both sevenths, we can combine this thing over one denominator. I didn't change these things. This is just a shorthand way of saying I got 2/7 of these and 3/7 of those. Because they're sevenths, we can combine them into one numerator without adding or combining them, and then have a common denominator there in the bottom. And you can put them right together. If they have the same denominator, you can put that line there and put them all over the same number. That's because you're allowed to split up denominators into pieces. I could go back and say, well, that's just 2x over 7 and 3y over 7 if I wanted to do something with this and do something different with that. I can split that denominator up, still the same denominator. I haven't changed its form. I may change its form, I just haven't changed its value. And then you can move on. Well, so you can split up denominators, but here's the thing, you're not allowed to split up, well, you're allowed to split up a numerator, but not split up denominators. Let me say it that way. This does not equal 3 over 2 minus 3 over x times y. It does not equal that. There's nothing else you can do with this. You cannot split that 3 up into 2 pieces. Okay? The bottom part saying is the ratio part. This is the part, that's the whole. And so you can say it's this much of the whole and this much of the whole, but you can't replicate that 3 and split it up, because this is a totally different expression over here on the right-hand side. It does not equal that. It just equals what it equals. And you don't have to do anything else besides that. I think I'll put up one more example about simplifying before combining. So I'll hit pause and have the board cleared and have the next thing up here. Okay, I'm going to use one full problem, and then I'm going to use another piece of the problem really quickly here. You need to look underneath that radical sign and see if there's anything that you can extract out of from underneath that. Stuff that gets kind of stuck under that radical sign and you can't work with it. So if there's anything that you can work with, like something that's already squared that you're taking the square root of, those are inverse operations, and so they undo each other, and that c squared can be pulled out. So here's something that I can deal with, and here's something that I can deal with first. I'm not going to try to combine these until I've dealt with the stuff under the radical sign. So the square root of c squared is c, and it comes out in front, and that leaves square root of 3 underneath the radical sign, and here I'll have 8, and the square root of c squared is c, and I'll have that. Can I combine these? Well, this is apples and that's oranges. So no, I cannot. And this one is done. Even though there's c's in there together, I can't do anything else unless I want to write it in a factored form. Lastly, I got this thing, and I want you to think of what could I pull apart and take out. And in that one lesson on factoring, I said, think of the first thing you can think of that is a multiple here. And I would say this is 16 times 10. And I know what the square root of 16 is. It's 4. 10 is 2 times 5, so I can't do anything with that. and that simplifies down, and that's as far as you can go. So only do as much as you can and then know when to quit.